In this video, we will use a 2D high-speed dynamic core mill. In this step, you will machine the outside profile using 2D high-speed dynamic core mill toolpath. Dynamic core mill machines the open pocket shapes or standing core shapes using the outmost chain as the stock boundary. The tool moves freely outside of this area. The inner chain defines the limit of the toolpath. They are designed to utilize the entire flute length of their cutting tools to maximize material removal while minimizing tool wear. First, to remove the toolpath display from your screen, press Alt-T on your keyboard. Now select Toolpaths, 2D High Speed, Dynamic Core. When the chaining dialog box appears, leave the default settings. Select the following chain as shown. Again, select the following chain. Once complete, select the OK button to exit the chaining dialog box. Select the OK button once more to exit the Chain Options dialog box. In the Toolpath Type page, the Dynamic Core Mill should already be selected. Next, we will select the existing 3/4 inch flat end mill from the list and set the tool parameters. From the tree view list, choose Tool. Input the following comment: Dynamic Core Mill the step. Once complete, select the cut parameters. Ensure that the step over value is 25%. If it is not, input a value of 25%. Change the approach distance to a value of 0.5. And finally, ensure that the amount to leave on both the stock and walls is set to 0. I will now explain a few of these parameters. Approach distance is available only when pocket machining is selected. This adds the specified absolute distance to the beginning of the toolpath's first cut. Step over sets the distance between cutting passes in the X and Y axis. Toolpath radius reduces sharp corner motion between cut passes. Micro lift distance enters the distance the tool lifts off the part on the back moves. Micro lifts are slight lifts that help clear chips and minimize excessive tool heating. Back feed rate controls the speed of the back feed movement of the tool. Retract controls retracts in the toolpath when making a non-cutting move within an area where the tool can be kept down or micro lifted. And finally, optimize cut order defines the cut order Mastercam applies to different cutting passes in a dynamic mill toolpath. Once the parameters have been adjusted, select Depth Cuts and disable it. You can now select the entry motion. Input a Z clearance value of 0.05 and a plunge angle of 2 degrees. Also, enable entry feeds and speeds and set a ramp feed rate of 10 inches per minute. Also, input a ramp spindle speed of 4,000 RPM and a dwell before cut spindle speed of 3 seconds. I will now explain a few of these parameters. Entry method defines the entry point and cutting strategy used to create the toolpath. Z clearance adds an extra height used in the ramping motion down from a top profile. It ensures that the tool has fully slowed down from the rapid speeds before touching the material. Plunge angle sets the angle of descent for the entry move and determines the pitch. Rapid feed rate overrides the feed rate set on the tool's page and uses the specified feed rate for entry ramps into the material. And finally, ramp spindle speed overrides the spindle speed set in the tool's page and and uses the specified spindle speed for entry ramps into the material. Once all of your parameters have been adjusted, select the linking parameters. Ensure that your Z value is 0.05. You can now select the linking parameters. Input a top of stock amount of absolute negative 0.75. As well, input an absolute depth amount of negative 1.5. Once complete, select the OK button to generate the toolpath. We will now backplot and verify the operation to ensure that the tool motion is correct. Select the backplot icon. Ensure that Tool and Workpiece are enabled. Select the isometric view and Fit icon. You can now press the Play Simulation button. Your toolpath will appear as shown. You can now exit Backplot. From here, select all of the operations. You will notice that both of the operations now have a green check mark. Select the Verify button. Ensure that Tool, Stock, and Workpiece are enabled. Now select the isometric view and Fit icon. Finally, press the Play Simulation button. Your part will appear as shown up to this point. You can now exit Verify.